The second part to the wire problem is that we've been asked to approximate the value of that integral using a trapezoidal sum. So I'm going to type it out for you. Remember, we have a 1/8 at the beginning in front of our integral, and then it's the actual integral part that we're going to estimate with the trapezoidal sum. That's the average of the two heights, so the average of the two temperature values, multiplied by the distance across the interval. So here's the expression I got. I have 1/8, that's the 1/b minus a, times the average of the first two temperatures, multiplied by the distance across the first interval, which was 1, plus the average of the second two temperatures, multiplied by the distance across the second interval, which is 4. I get this equals 75.6875. If you got 605.5, you made a very common mistake, and that's to use the trapezoidal sum to evaluate the integral, but then forget to divide by the 8. And that's why I want you to think about this. If I ask you about the average temperature of the wire, and the wire in one place is 100 degrees, and the wire in another place is 55 degrees, the average has to be somewhere between 100 and 55. If you got 605, you know something's gone wrong. And it's probably that you made that common mistake. They always watch for that on the AP test. And I have one last thing to do on this problem, which is to name the units. So, the way to figure out the units is to remember that an integral is a sum of a bunch of areas of rectangles. So, this is the expression that I evaluated, 1/8. That 8 in the denominator, that's the difference between 0 centimeters and 8 centimeters. So the units is 1/centimeters. I'm going to write that. This is 1/centimeters. And then I'm going to multiply by the integral. That's a multiplication sign. And the integral adds up a bunch of areas of rectangles. And those rectangles have a height that's t of x and a width that's a small change in x. So the height is degrees Celsius. And the dx, that's a change in centimeters. So I have units that are 1/centimeters times degrees Celsius times centimeters. You can probably see that these are going to cancel, and my final answer has units of degrees Celsius. And doesn't that make sense? I asked you what the average temperature of the wire is, and we measure temperature in degrees Celsius. So it should help you make sure that you've got the right units there. So 75.6875 degrees Celsius is the average temperature of the wire. All right, we got one more practice problem here. I've been given a function, L of t, which is the rate at which people turn left. And I have this problem. Traffic engineers will consider restrictions whenever L is greater than 150 cars per hour. So let's find all values of t for which L is greater than or equal to 150. This is not a trick question. It's not a calculus question. So it's not normal to get asked this on the AP test, but we can answer this question. Does L of t ever equal 150? Well, here's 150. And we can see that there are two places where L of t does equal 150. Do not try to estimate. Use your calculator, solve this equation on your calculator. L of t equals 150. I know this is mirror image for you, but remember, this is how we're going to do this. We're going to graph y equals 150. And we're going to graph y equals the function they gave us for L of t. And you're going to graph them and use the intersection function on your calculator to figure out the two x values at which those graphs in. All right, so look, notice I've written the equation that I solved on my calculator. L of t equals 150. I got two solutions, 12.42831 and 16.12167. The last part is I've been asked to compute the average value of L over this interval. So this is how I would write my final answer. I would define A to equal 12.42831, define B to equal 16.12167, and then write the expression 1/b minus a times the integral from a to b of L of t dt. That's the average value of L of t on the interval between those two. Number of left-hand turns, the rate of the left-hand turns is equal to 150. And when I use my calculator to simplify, to use front end, I get 199.4259, and that's cars per hour.